Today we're solving systems of linear equations by a process called elimination. The TLOs for this are: I will identify additive inverses between two equations in a system. I will rewrite equations to create a pair of additive inverses, and I will use elimination to solve a system of linear equations. As in our previous notes, I gave you a step list to follow if you get stuck, so let's read through the steps. A system of linear equations may be solved using a method called elimination when a variable is removed by adding or even subtracting equations. Step 1, recognize any additive inverses or multiply one or both equations by a constant so at least one pair of like terms has an additive inverse. Step 2, add the equations to eliminate one of the variables. Simplify and solve for the remaining variable. Step 3, substitute your solution from step 2 into either equation to solve for the second variable. And step 4, write your solution as an ordered pair. And of course, as always, step 5 to check your answer, make sure it's actually valid. Let's review additive inverses. By definition, additive inverses are pairs of numbers whose sum is 0. So 8 and negative 8, when you add them, equals 0. They could also be defined as numbers with the same absolute value or distance from 0, but they do need to be opposite numbers. 3y and negative 3y are also additive inverses. Those are variable terms with coefficients that are opposite of each other. So 3y add negative 3y equals 0, or commutative property, negative 3y add 3y equals 0. Let's go ahead and apply that. It says solve the system of linear equations by eliminations. And so our first step is to identify the additive inverses. Right here, negative 2x and positive 2x are additive inverses. That means if I were to add them, they would become 0. And so that's exactly what I'm going to do. I'm going to add this system vertically. So let's start with the negative 2x plus 2x, which is, let me go ahead and write it this time. Next time I won't write it, but 0x. Then we have 3y subtract y. Now that's 3y subtract 1y. The coefficient is 1. 3 minus 1 is 2, so I'll have plus 2y equals. Then we add 4 and negative 8, which equals negative 4. What I could have jumped straight to is 2y equals negative 4. And from here, we use the division property of equality to solve for y. Y equals negative 2. Now that we've solved for one of our variables, it's time to solve for x. You can choose either equation to solve for x by substituting the y. Usually by default, I go with whatever one looks easiest, or if neither of them look particularly easy, I just go with the first one. So I'm going to go with the first one. Negative 2x, add 3 times y. Y is going to be substituted, equals 4. And we're substituting y with negative 2. So let's simplify. The first part, negative 2x, remains. 3 times negative 2 is negative 6. Now I could either write that as plus negative 6 or I could write it as subtract 6. I'm going to go ahead and write it as subtract 6 since there's less symbols involved. And then equals 4. To solve the two-step equation, I'm going to begin with the addition property of equality. I'll add 6 to both sides, which, by the way, those are creating additive inverses. Negative 2x equals 10. And then division property of equality. Divide both sides by 2. X equals negative 5. We have y, we have x. Let's write our solution as an ordered pair. Negative 5 for x, negative 2 for y. So the solution negative 5, negative 2. And we will check our answer. In the original equation, let's start with the first one. It says negative 2x. I'll be substituting x out. Plus 3y, we'll be substituting y out, equals positive 4. With the x, we have negative 5. For the y, we have negative 2. Negative 2 times negative 5 is 10. 3 times negative 2 is negative 6. And 10 add negative 6, or 10 subtract 6, does equal 4. So that one checks out. Our second system, or a second equation in the system, 2x, we'll replace the x, minus y, where we'll replace y, equals negative 8. And replacing x with negative 5, replacing y with -2, and simplifying, we get 2 times -5 is -10. Subtract -2 is the same as adding +2. -10 plus 2 is -8, so the solution checks out. The point -5, -2 is the solution of the system. Moving on. Example 2, solve the system by elimination. The x coefficients are 2 and 6, which are not additive inverses, but the y coefficients, 5 and -5, that's what subtracting 5 is, right? If I were to add the opposite, it'd be plus -5. So those are additive inverses. We can begin by adding and eliminating the y term. 2x add 6x is 8x. I could write plus 0y, but I could actually just skip that, just recognizing that 0y's is now eliminated. And then 17 add 9 behaves like 17 subtract 9, which equals 8. Now I could have actually written, like I said before, 8x and then not written the y term at all, equals 8. By the division property of equality, we can divide by 8, solving for x. X equals 1. Looking at both of my equations, neither of them look particularly hard nor easy, so I'm just going to default and use the first equation in the system, rewrite it with a substitution. We'll be removing x, and then we have plus 5y equals 17, and replacing x with 1. 2 times 1 is 2, plus 5y equals 17. Subtraction property of equality will subtract the coefficient, or the constant term, constant term 2. Isolating 5y equals 15. And the division property of equality, divide both sides by 5 to solve for y. Y equals 3. Now that we have our x and y, we can write it as an ordered pair. X is 1, y is 3. So it appears the solution is 1, 3. Time to check. 2 times x will be replaced, plus 5 times y, which will be replaced, should equal 17. We have 1 and 3. 2 times 1 is 2. 5 times 3 is 15. 2 add 15 is 17. And that one checks out. The second one the second equation in our system, 6 times x, which will be replaced, subtract 5 times y, which will be replaced, should equal -9. X is 1, y is 3. 6 times 1 is 6, minus 15. And 6 minus 15 does in fact equal -9. So the point 13 is confirmed to be the solution for the system. In examples 1 and 2, we had additive inverses in our system. Here in example 3, we do not have any additive inverses. We have 3x add 2y equals -2. We have -6x subtract 5y equals 2. So we're going to use elimination. Of course we have to use elimination. That's what's in the instructions. Both of these are written in standard form, and neither of them have really nice looking intercepts. If they had really nice intercepts, I might consider graphing if this was allowable. But again, this is the elimination note, so we're going to use elimination. So what I need to do is compare the coefficients for the x variable and compare the coefficient for the y variable. Now, interestingly enough, 3 and, let me just call it 6 for a moment. If I were looking for their least common multiple, the multiples of 3 are 3, 6, 9, 12, etc. And the multiples of 6 are 6, 12, etc. I have several common factors because 6 is actually broken down into the prime factorization 2 times 3. Their least common multiple is the number 6. So I could create my additive inverses by simply changing the 3x plus 2y equals -2 using the missing factor, the 2 that's missing. So that's the way I'm going to be taking. But I do want to mention that the other coefficients, 2 and 5, if I were to do the multiples of 2, 2, 4, 6, 8, 10, and then 5, 10, 15, 20, etc. Their least common multiple is 10, and so you could actually change both systems, but I always like to choose the path of least resistance, the one that's going to use the least amount of work. So I'm going to work to eliminate the coefficient x. So let me rewrite this expression. We're going to multiply the whole entire thing by 2. In order to do that correctly without losing the value and to keep it proportional, the left side gets multiplied by 2. And anything I do to one side of an equation, I have to equally do to the other side of the equation. So I am going to use the distributive property on the left to get 2 times 3x is 6x, and 2 times 2y is 4y. And on the other side, 2 times -2 is -4. So I've rewritten my system, or the first equation. Let me rewrite the system. We'll have -6x minus 5y equals 2. Now I have a pair of additive inverses, so I can eliminate the x variable through adding the equations. 6x add -6x is 0. 4 add -5 is -1y, or you could write it as -y equals -4 add 2 is -2. Finish up by dividing both sides by -1. Y equals 2. To solve for x, I can pick either of my original equations, and I could even use the new one in red, but I like to go back to the beginning before I made changes, just in case I've made any errors on the way. I'm going to replace the y in the first equation. 3x plus 2 times y, which is replaced, equals -2. And we are replacing y with +2. Let's simplify. 3x add 2 times 2 is 4 equals -2. To solve the two-step equation, we'll first subtract 4 from each side, getting rid of our constant on the left. -2 subtract 4 is -6. And the final step, division property of equality, divide by 3 to get -2. So our solution appears to be the ordered pair. X is -2, y is +2. Let's check both of them. And if you'd prefer to just type them in your calculator, you can very quickly do that. You're welcome to. Or if it's an easy mental math problem, you can do that as well. So 3x plus 2y equals -2. We'll make the substitution. We'll have x is -2 and y is +2. 3 times -2 is -6 plus 4 equals -2. -6 plus 4 really is -2, so that one checks out. The second equation has -6x minus 5y equals 2. With the substitutions, x is -2, y is +2. -6 times -2 is 12. 5 times 2 is 10. And 12 minus 10 really is 2. And so it checks out. Let's keep working examples. Example 4, we have coefficients on our system of -2 and 7 for the x, 15 and -5 for y. Now, let's go ahead and have you pause the video at this point, try example 4 out, and when you're done, unpause the video to check your answer. Or you could check your answer in steps. You could do the first step, unpause the video, see if you're right, pause the video, do the next step, unpause, see if it's right, and then go from there, since this is basically a 5-step process. Okay, students, let's check how you did. I'm going to be working with the coefficients for y because 15 and 5 have the least common multiple of 15, so 5, 10, 15. Since the first equation already has the 15 on it, I don't have to make any changes for it. I do need to make changes. Let me change color actually. I do need to make changes to my second system. In order to get the multiple of 15, or the coefficient of 15, I'll multiply by 3 on both sides. So that it becomes 3 times 7x, which is 21x, subtract 3 times 5y, that's distributed property, right, is negative 15y, or subtract 15y, and then 3 times 7, let's see, 3 times 7 is 21, and then 3 plus 2 is 51. And now we have an additive inverse in our system. Let's go ahead and add now. The coefficients of x, negative 2 plus 21, would give us 19x. 15 add negative 15, or 15 and then subtract 15, behaves as plus negative 15y, is 0. And on the other side, we have 51 and negative 32 added, which will behave like 51 subtract 32, which is 19. So 19x equals 19. Division property of equality will divide by 19 to get x is equal to 1. Now that I've solved for x, I get to solve for y. And I think I actually prefer, let's see, I'm going to use the second equation. Just telling you what I'm doing here. So use 7 times x, which will be replaced, minus 5 times y equals 17. So I used the original one, not the one that I changed using the multiplication property of equality. X equals 1, so the substitution, 7 times 1 is 7. Subtract 5y equals 17. The subtraction property of equality, divide both, or subtract both sides by 7. We'll have negative 5y equals 10. And divide both sides by negative 5 using the division property of equality to get y equals negative 2. The solution to our system will have x value 1, y value negative 2. To finish it off, we'll check by substitution property of equality. Our first one is negative 2x, which will be replacing x, plus 15y equals negative 32. Since x is 1, y is negative 2. We'll have negative 2 times 1 is negative 2. 15 times negative 2 is negative 30. And negative 2 plus negative 30 does in fact equal negative 32. Second equation, we basically did this one right above us, but let's do it again. We have 7 times x minus 5 times y equals 17. X is 1, y is negative 2. 7 times 1 is 7. Let's call this negative 5 times negative 2, which is positive 10. And 7 add 10 does equal 17. The point 1, negative 2 is the solution of the system. Example 5 reads, a small business with 2 locations buys 7 large delivery trucks and 5 small delivery trucks. Location A receives 3 large trucks and 2 small trucks for a total cost of $270,000. Location B receives 4 large trucks and 3 small trucks for a total cost of $375,000. What is the cost of each type of truck? Let's go through and define our variables. We're looking for the cost of each type. So our large trucks, let's just call those L. Try that again. Let L be the cost of large trucks. And let S be the cost of small trucks. Let's write a system. First, let's describe location A with an equation. So location A, we have 3 large trucks. So 3 times L, 3 large trucks at the unknown cost, and 2 small trucks. So combine that with the 2 times the cost of the small trucks. And location A is the total cost, 270,000. Let's write an equation for location B. We have 4 large trucks, so 4 times the cost of the large trucks, and 3 small trucks, so 3 times the cost of the small trucks, for a total of 375,000. Okay, we have no coefficients that are additive inverses. It's really up to you at this point what you want to do. I personally like to work with whatever coefficients happen to be the smallest. So the L coefficients are 3 and 4. The S coefficients are 2 and 3. I think 2 and 3 are the smallest, so I'll work with those ones. The least common multiple of 2 and 3 is 6. 3, 6, 9, 2, 4, 6. So that's what I'll be working with. The other thing is both of them are positive. So one of them I would like to multiply through to make a coefficient of -6. So on location A, I'm going to multiply both sides. Okay, I'll multiply this one by +3 and then give my new location A equation. So distributed property, 3 times 3L is 9L. 3 times 2S is 6S. And then 3 times 2,700. Let me use my calculator just to be on the safe side, even though I'm certain I could do it. I just want to be safe. 270,123 multiplied by 3. Yeah, 81. 810123. Okay, our next one, I'm going to, let's see, newbie. Like I said, I need additive inverses, so I'm going to multiply through by -2. When I multiply through by -2, then one of them will be the additive inverse and they'll be ready to simplify and cancel. -2 times 4L is -8L plus -2 times 3S is -6S, which will be my additive inverse. And then 375 times -2, let me just do this one again in my calculator just to be safe. 375,000 times 2, which is negative, so it will be -7,500 or 750,000. Now when we add 9L subtract 8L is a single L, which you don't have to write the coefficient of 1. 6x S plus -6S is 0, so it's gone. And then 810,000 subtract, well, it's plus -750,000. It behaves as subtraction, so 700, 60,000. Remember our variable L stands for, let me move my calculator, it stands for the cost of the large truck. So a large truck is $60,000. Now, if you guys know anything about buying cars, that's a pretty high price, but for a delivery truck, that's actually probably really reasonable. On S, the cost of small trucks, we're going to go ahead and find the answer. I'm going to use my location A equation to solve for that. So let me give myself a little space here. I'll have 3 times the cost of the large truck, which is $60,000, plus 2 times the cost of the small, which we don't know yet, equals 270,123. All right, 3 times 6 is 8, so I'll have 18. 3 times 6 is 18, and then 4 zeros, 1, 2, 3, 4, plus 2s equals 270,123. Subtraction property of equality will subtract 180,000 from both sides. 2s equals, let's see, 27 minus 18, 90,000. Then divide both sides by 2. So 90 divided by 2 is 45. So this will be s equals 45,000. I'd like to write my answer as an ordered pair, but there's no dependent thing. It doesn't matter how many large and small trucks you buy, it doesn't affect the other one. So when I write my solution, I do need to define what I'm doing. So if the solution is, I'm going to run out of space again. I'm going to write in my bottom spot here. I'm going to define large then small just because that's the order I wrote it in. That's the order it came in the paragraph. And so the large truck's 60,000, comma, the small truck's 45,000. Let me go ahead and grab my fancy graphing calculator because I want to check my answer. And I don't really have a lot of space, so I'm going to just pop it in there. So if I wrote my system of equations wrong, but I test my answer in my incorrect system, I'm going to get telling me that's right. What I'm going to do instead is I'm going to go through the paragraph with my answers and see if it's right. Location A receives 3 large trucks. So 3 times 60,000. So we spent $180,000 on 3 large trucks. 2 small trucks, 2 times 45,000. And then combined with the large trucks, and that matches our location A price, $270,000. Location B receives 4 large trucks. 4 large trucks cost $60,000 each. And so $240,000 for the 4 large trucks. And then 3 small trucks, we have 3 and the 45,000. And then add that to the large trucks for 0, 0, 0. And it matches 375,000. So the solution is correct. Last thing I need to do is just write the sentence. Large trucks. What color do I want? I'll just simply red. And small trucks. All right, students, if you need to, you can pause and go back, or you can use the speed up tool, whatever it is. But let me know if you have questions on that one. Let's finish. Example 6, the theater club sold 101 tickets to its first play. The student ticket cost $1 and an adult ticket cost $2.50. The total ticket sales were $164. How many of each type of ticket were sold? So the question tells us what we're looking for is a quantity of how many. And we have 2 types of tickets. We have the student and adult. So I'm going to define my variables. Let S be the number of student tickets. And let A equal the number of adult tickets. The first piece of information we get is that we sold 101 tickets. It didn't specify if those are adult or students, so that must be the total number of tickets. So my first equation in the system will be student tickets plus adult tickets the number of students plus the number of adults is 101 tickets altogether. The second system in the equation has to do with the money. We have $1 for a student ticket. So the coefficient of S would be 1S. I'm going to just write that as S instead of writing it as $1 times S. So if I buy 1 ticket, it's $1, 2 tickets, $2, etc. You don't need the coefficient for that. But you do need the coefficient for the A, which I'm going to just separate this a little bit. So S plus, I'm going to call it $2.50, 2.5 A. So multiply the adult tickets by $2.50 and then add the cost of the student tickets. It gives us a total of sales 164. So you can see here that we have almost additive inverses. One of our equations should be positive, one should be negative. I kind of wish I had written this in the other order because personally for the mental math it'll be easier. So I'm going to do that. I'm going to actually write the money on top. Plus 2.5 A equals 164. So it doesn't matter the order of our system, both of those equations are involved. And I am going to multiply this one through by -1. What that will do for me is give me a system that I can quickly subtract. So S plus 2.5A equals 164. And then the next one will be negative S actually subtract A equals -101. And then we'll add them up. S subtract S is 0. And then maybe I do want the dollar sign on here. $2.50 minus $1, or 1 is the coefficient, so that'd be 1.5 A. And 164 subtract 101, we'll have 363. Division property of equality, we'll divide 63 by 1.5. And just to be safe with my calculations, 42 adult tickets appear to be sold. Of the two equations that we wrote, that one in black looks really easy to solve. S plus A, but 42 is A, so S plus 42 equals 101. Subtraction property of equality, we'll subtract 42 from 101, leaving me with, let's see, 11, 9, 9, 5, 59 student tickets. When I write my ordered pair, I think I'll write, let's see, what did it give me first? Student tickets. I'll do student tickets first. Student and adult. So student is 59, adult is 42. All right, I'm going to grab my calculator to check. I'm also going to remember to use the paragraph. If I use the paragraph, if I had written my equations wrong of my system, I would be unwise to check the one that I wrote because it wouldn't catch that mistake. So let's go ahead and just do the first paragraph that says the theater club sold 101 tickets to its first play. So if 59 were students and 42 were adults, there's 101. So that part works out just fine. And then let me use the other calculator. It'll be faster. All right, so student tickets are $1 and $1 for student tickets, that's $59. $2.50 times the 42 adult tickets, 164, and the total says 164. So it worked out. We checked it by the paragraph, and we have our solution. So let's write a sentence and finish it up. The theater club sold 59 student tickets and 42 adult tickets. And we're done. Thank you for joining me for this lesson, students. We'll see you in the next one.